Hello everyone, welcome to Answer Kari, and in this video we will be starting with combinations. Before getting into the understanding of combinations, I would suggest if you could watch the second part of the permutation and combination series, in which I have explained the difference between permutations and combinations. It would give a better and clear understanding. So we'll directly move on to the understanding of this formula. The number of combinations of n different things taken r at a time is given by NCR, which is equal to n factorial divided by r factorial into n minus r factorial. Now if we recall the formula for permutations, it was n factorial divided by n minus r factorial. For this particular case if we talk about. But here what happens is we are dividing this formula by r factorial. We are dividing this particular formula by r factorial, and hence what happens is the denominator gets multiplied by this numerator, and then we get the formula which is n factorial divided by r factorial into n minus r factorial, which is the formula for combinations. Now to understand the reason why we divide by r factorial, we need to look upon this example. Again, I would shed some light on the part 2 video of this series in which I have explained kinda in the same way. So now what happens is if we take n to be a, b, c, d, like 4 people, which is equal to 4, and r if I choose to be 3, which is any 3 people. So the selection here matters. What matters here is selection. Now for example, right now I select 3 people b, c and d. I could have selected a, b and c also, but right now I'm selecting b, c and d. So what happens here is if I select B, C and D, the ways of their arrangement can be arranged in this particular way, or in this particular way, or in other several ways also. So the number of ways, as we all know, comes with the permutation formula, which will be 3 factorial, right? R here is equal to 3, so it will be 3 factorial. But we do not need this. That is what I have just said. In combination, the order or the arrangement does not matter. What matters is selection. That is the reason why we divide by r factorial. So what happens here is this whole formula gives us just the ways of selecting and not the ways of arranging. Moving on to the first question. How many selections of 4 books can be made from 8 books? Now, we need to select 4 books out of 8. Now, the question says selection. The question talks about selection, which should remind us about combination. So, we'll use the formula NCR. I'll write first n factorial n minus r factorial. It is important to subtract r from n first and then we use the factorial since we have been doing this for long. Now n factorial, n here is what? From 8 books. So total number of objects that we have is 8 and what we need to select at one time is 4 books. So r will be equal to 4. So it will be 8 factorial divided by n minus r will be 4 factorial. Then again r will be 4 factorial. To solving this, 4 factorial gets cancelled and 4 factorial is 24. So it 1s are 3s are then 2s are, which will be 70. So 70 will be our answer to this question. So there are total 70 ways of selecting 4 books out of 8 books. Now we'll be looking at various types of questions. In these questions, what happens is just the language is changed. The concept remains the same. A baseball team has 13 members. So n is equal to 13. We can correctly make it out. How many lineups of 9 players are possible? Now lineups means kinda like queues, right? The difference is just that the position of each member in the lineup is not important. So position here refers to order or the way of arrangement. So it clearly says that it is not important. So again we'll use the formula for combination. So we'll write our NCR. Directly I'll write her 13 factorial. Then we'll have 4 factorial, 9 factorial. Again this is 24, so 12, 1, 2. And we have 5 here. So if we multiply 13, 13, 143 into, which will be equal to 715. So this will be our answer to this question. Now the next question says 12 persons meet in a room and each shakes hands with all others. Find the number of handshakes. So right now we have what, 12 people. They meet in a room. This question can be a bit tricky, but trust me, it is very simple if you get the concepts right. 12 persons meeting in a room. So we can take n to be 12 because obviously there is no other number given. Now what they say is that each person shakes hand with all the others. Now if there is one person out of these 12, he will shake hands with all the 11 people, right? The rest of 11. But when this particular person shakes hand with all the 11, all those 11 people also shake hand with this particular person. So here the order does not matter. That is who is shaking hands first or the ways of arrangement. This thing does not matter. The only thing that matters is selection or who two people are shaking hands at one time. So what we'll write here is 12 C2 because two people are shaking hands at one time. Now in this case we'll directly write 12 factorial, then 12 minus 2, which will be 10 factorial, multiplied by 2 factorial. Again we'll just solve it quickly. So the answer to this question will be 66. So there will be total number of 66 handshakes. Now what the fourth question says is, from a class of 25 students, 10 are to be chosen for an excursion party. There are 3 students who decide that either all of them will join or none of them will join. So there are just 2 options. In how many ways can the excursion party be chosen? So now, in general, if the question was still here, what we would have done is 25C 10. Simply, nothing else. But in this case, there is this condition, so we won't do this. What we'll do is we'll have to make 2 cases. Case 1 and case 2. Why 2 cases? Because there are 2 options. Either an or का case बन रहा है. So either the 3 students will decide. So one case will be that all the 3 students they do join the party, and the other case will be that none of the 3 students join the party. If we take the case that all 3 of them will join the party, what happens is first we'll subtract. So n here is equal to 25 and r here is equal to 10. In the first case, what happens is we subtract 3 from 25 because out of these 3 we do not have to select because they are included, they are compulsory. In other words, if we say this, so we'll be left with 22 choices, options, or perhaps students. Then from r also we need to subtract because here also we have placed or included those 3 students. Hence we'll subtract 3 from 10, which will be 7. So the formula here will be 22C7. We have subtracted from both because 3 students are compulsory that they will join. तो वो यहाँ से भी subtract हो जाएंगे and यहाँ से भी. I have explained this in the permutation formula also. These two cases are very similar to the case in permutations where the options are like whether a particular thing is included or not, or maybe many things are included or they are excluded. So this is the case for inclusion and this is for exclusion. Now in the case 2, what happens is again we have n is equal to 25. Again we'll subtract 3 from n, but we won't subtract 3 from r. The reason being we need to select 10 students out of those 22 because neither of those 3 students will be joining. So we'll write here 22C10. So the answer for this will be 170544, and this after calculating will be 646,640,46. So now we need to add these two cases. Why do we need to add and not multiply? We'll look upon this principle later on as well. But for now, we are adding because the option says or. In the conditions of and, what we do is we multiply. But when the option is of or, कि या तो ये या वो, then what we do is we add. These are two very important conditions that we need to remember. So in this case, these are just options. That the ways of selection if these three will be joining, and the ways of selection if these three will not be joining. These are the two cases. So after adding, we'll get the answer. It is 817190. This will be the answer, or the total number of ways of selection of students with this case included, with this condition included. Thank you.